Good morning, students. So, in today's video, we move to our next experiment, which is experiment 4B. So, in experiment 4A, we implemented horizontal fragmentation. So, here in experiment 4B, we will be implementing vertical fragmentation. Now, as told you earlier, fragmentation is one of the feature which actually brings in flexibility related to performance and more query optimization when it comes to dealing with distributed database. So again, as a prerequisite, for this experiment, you should be knowing the working with the SSMS toolbox. Then again, what fragmentation is, what is vertical fragmentation, difference between vertical and horizontal fragmentation, and then also knowledge of creating the link servers in the distributed environment, which we already studied in experiment 3. So when it comes to vertical fragmentation, here we don't use the condition to make or fragment the master table. However, here we select a few attributes out of the master table to create the vertical fragment. So it is a column wise fragmentation rather than the row wise fragmentation. Okay, so to explain you what actually we are going to do in the project, I am considering the same schema, the project one, okay, which has the attributes of project number, project name, budget, and location. So here we are not going to split it row wise, but we are going to split it vertically. So when we are doing vertical split, I am using a strategy like few attributes to be stored on fragment one. So I have created a database on the another location, okay, and then I have let's say created the first fragment and then use it. So this is how you actually create the fragment, where in this fragment I'm storing the two attributes, which is p number and budget, and in the second fragment I'm storing p name and budget. Okay. So in the first fragment, p number and budget, right, and in the second fragment we are storing p name and project number and name, also the location. So this is the second vertical fragment. So once the fragments are created, then we can execute the queries. Now when we were working with horizontal fragmentation, we were firing the queries on individual fragments and then combining the results using the union operator. Here it is not done that way. Here you need to use the join queries, right? And when you're joining the two, like in for example, display the names of all projects and their budget. So the project details, they are scattered on both the fragments. So select name and budget. Name is coming in from the first fragment, second fragment, and budget is coming from the first one. So you are supposed to mention the entire location on this server, in this database, in this table. Okay, and the key one here is the alias, which is used as the for this entire table. Okay, and outer join the second destination table. So this is and we are the joining constraint is the project number, which is a common attribute in both the fragments. So once we join it, then we can retrieve the results accordingly. So this is how you use the outer join operator in spite of the union operator in vertical fragmentation. Okay, so we look at the practical demonstration of the same when it comes to vertical fragmentation. So I switch to SSMS. Here you can create a new database. Okay. Rather than doing that, I just just a minute. The SSMS is loading up. Then go in that way. So I am on S1 right now. Okay. Or else to avoid confusion, I'll use this which has no name here. So I'm using this server. Go to new query. create the database. Database we need to create is employee, I think. And just copy this thing where we also create the table. Then we create and insert to data index. View the contents of the employee table. Okay, so you have this and now you want to fragment it. Now when you're fragmenting it, I'm using a strategy in where I'm putting the details like employee number, employee name and address. That is the personal information on server 1 and rest of the information on server 2. So before that, what you need to do is go to server 1. Okay, you need to have a link server on this particular master table. So go to server objects, check the link servers. Okay, we have no link server created here, so you'll go ahead and click the new link server. Okay, since you know want to get the name, you can just go here, database engine. This is the server to which I want to create the link server. Come back to the window, see in the name SQL server, security options you need to add. Provide the credentials. And once a link server is created, you should be able to access the data inside it. So you can see the tables here. Yeah, the employee database, and inside employee database, we have created this. If you try to query script table as select into new query editor, you will get the entire naming constraint that you are supposed to follow. Okay, so here you can see the table, it will load up. So prior to that, on S1, we'll create a database. So I'll just get it ready. See here, you will get, where are we right now? We are inside the server S1. Inside that, we created a link server to the master server. I'm calling the master server because this is where your master table is residing, wherein you want to create the fragment. So this is the table employee inside that this. So when you do right click script table as, this window opens up, and to avoid any confusion or error, straight away copy this. Okay. So while creating the fragments, you will need this naming constraint. So I'll go to this server S1, and there I'll create a database. Okay, I have not yet created, so I'll create a database over here. I'm just copying the sentence from there. Okay, so create. I'm doing employee VF1. So I'm going to store there the vertical fragment 1. So I'm just doing it that way. This I'm doing on server S1, and I'm creating the first fragment. Okay. Once that is clear, then you need to select which attributes do you want to place in. Okay, so I want to create my first fragment to have employee number, name and address into this table. From where? So there you need to copy this from this server EMP table, and this is the employee table. So you just execute this. Ideally, if you see, we did not create this employee, we did not create this table named as EMPVF1. It gets auto created. Okay, and then you can always check what are the contents of that. You will select start. Let's start from. Okay, so it is three attributes is the first fragment created. Okay, same process you need to repeat on server 2. Go to server 2. Okay, create a database over there. So server 2, new query, create a database, use that database. Okay, now this time we store different attributes. What attributes we will store? Okay, employee name, number and salary, also designation into this is the new table that will be created, but from where? From where? From the master database. So your master database is here, so you need to communicate through link server. So you need to be on server S2 and check. There is link server created to S1 but not to the master one. So you go ahead and create one. For name, you can just copy it, get it from here. Put in the name, SQL server, security, you add the impersonation required. Provide the credentials. Inside this, when you will explore, you will get all the databases which are there on the master server. So there, why we are doing this? Because first you need to communicate it, access it, the entire master table, and then create fragment. And also, when you will do right click and script table as, you will get the entire naming constraint that has to be followed to communicate to that particular table residing on the server. Ideally, it is going to be same. It has to have from. Okay, so execute this. then we can just check the contents. The name of the table fragment is EMP, which we have 2. Okay. So if you see both of the fragments, they have 5 rows here and 5 rows here. However, the attributes in the fragment 1, we wanted employee number, name and address. And in fragment 2, we wanted employee number, name, salary and designation. Okay. So once this is created, then you can start firing the queries from any of the, let's say, any of the servers. Okay. So when you are firing the queries, you are supposed to be using uh, outer joins. Like in, I'll just demonstrate it from this one. Let's say I want to fetch an employee name here in spite of the project name. So I'll write here email and I want to fetch the salary information. So I'll write salary and also the designation. So from where? So from the first fragment which is residing, this is your first fragment. Now how will you come to know the first fragment? The naming constraint, select the database here. We created yeah, this is the first fragment that we created. So go there. Inside that, the table you will find is EMP VFH1, which we have created right now as a fragment. This one. Right? So right click, split table as. I'm doing this just to get the proper name. So you have this split. It resides in which table? You need to put your table name over here, which is EMP VF1. Okay, and it is residing on server 1. And where are you firing the query when? You're firing it on server 2. So here on server 2, you don't need to, you can just check your database which you have created. Go to server 2, check the name of the database, check the name of the fragment. Okay. This is the name of the, okay, this is the name of the database. The name of the table, we can get it from here. It is this itself, right? EMPVSS, we created just now. Right? And the server names, if you see, they are not correct over here. So I need to specify the correct server names. Okay, and both of them, the common attribute is e number. See, you're firing the query on server 2. So for server 2, your fragment, this is not required. Okay, you can directly just specify the table. Why? Because it is a local one. It's a local table. Whereas for fragment one, since it is residing on some other server, this is to be mentioned. To be on the safer side, you can mention on both. See, it is saying ambiguous column ename. So since ename is present in both our fragments, it is populating this. So in that case, I can just write in as, let's see if P1 suffices. Otherwise, we can write the name of the table itself. P1 is the aliasing I'm using for the first fragment. So it is taking the name from the first fragment. Okay, salary and designation. So if you have seen our fragments were, first fragment has only personal information, which is related to employee number, name and address. And second fragment, it had information related to, like if I have to tell you show you the first fragment, yeah, there is the second fragment. Okay, it has the professional information. And if you want to check both things, I'll just combine here, wherein you get the outer join operator, and this is how you actually query the vertical fragment that you have created. Okay, so what you guys are expected to complete is, this is the schema which is uploaded on Moodle both for 4A and 4B. So in experiment 4B, that is vertical fragmentation, you are supposed to create the first vertical fragment. See, first thing, you might have already created these two tables for experiment 4A, right? Let's say on server 1. So server 2 and server 3 will be containing your two fragments, which is vertical fragments. So first fragment of employee table with personal information, you can create it on server 2, and second fragment on server 3, and then you're supposed to execute these two queries and retrieve the results. So when it comes to standard output, what is expected in the output is just open the standard output file. Okay, so in the standard output, I need one screenshot of your master table, then the query of fragmentation for first fragment and the screenshot of the first fragment, query and screenshot of the second fragment. Okay, then finally the two queries that are a part of your task and the screenshots of that. Okay, so you write the entire query question, the SQL query itself, and then the screenshot of it. So this is how you need to compile your standard output for experiment 4B, that is vertical fragmentation. Okay, thank you for your patient listening, students.